Okay, one more conic section to look at, and this guy is the hyperbola. And of the four, the hyperbola is the hardest one to kind of wrap your mind around. The formula isn't so bad, but it's still kind of, again, the hardest one to kind of get the idea across. The definition here is really kind of hard to understand, but the way I like to think about it is it's like an ellipse turned inside out. Okay, so if you take the oval or the ellipse and you kind of turn it inside out. So let's draw a picture first, and let's say we have two foci. So we'll have sub 1 and sub 2. So this time what we're going to do is, instead of just putting one line or one string and putting our pen in and going like this, what we actually do is we take, so there's our string, okay? So our string is still going around our two foci, but what we do is we stick a pen here, and we pull the pen back and forth, but as we do that, if we pull this one this way, this pen is gonna come in, and if we pull this one back this way, this one's gonna come down. So we're not actually ever able, we can't actually get all the way over here because this pen is pulling in the opposite direction. So what it ends up making is kind of a weird shape. It ends up looking something like this. It looks like almost like a parabola going that way, and then this pen over here is creating a parabola going that way. So a hyperbola is like two parabolas facing away from each other. So you see what I mean about how if they had turned in, it would look more like an oval, but if it's like taking that ellipse and just turning it inside out. And the reason why is because when we think about the distance that we're looking at, we're not looking at the sum of the distances, we're looking at the difference of the distances. So the difference of the distances will always be the same from the two foci. So let's just write that down here. So we say an ellipse is a shape centered around two foci in which, and it's actually the absolute value of their distances, so the absolute value of the distance between the two foci is always equidistant. Always equidistant. So it is kind of a weird looking shape. So just like all of the other ones, this doesn't need to be on the XY graph, but because this one is so weird, we're gonna go immediately to the XY graph. So let me graph an ellipse again. And when we graph an ellipse, and I'm just gonna go with a real basic one, centered right at the origin, just to make our life easier. Okay. So let's say it looks like, actually, you know what, I'm gonna go the whole way. So what I'm gonna do is I'm gonna create what we call the guide box. Okay, so this guy is the guide box, and this is how we're gonna go around about graphing any ellipse, is with this guide box to make it look a little bit better. And, excuse me, and then what we're gonna do is we're gonna draw the diagonals through the box. So we have a diagonal that comes all the way down through the box this way, and we have the diagonal line that comes all the way down the box going this way, okay? Now, all of that is dashed in because none of that is actually our graph yet. Our graph is going to sit in here. So think about these as like asymptotes. The graph is going to sit inside that kind of arc right towards those diagonal lines. And then it's going to do the same thing over here, arc down, come in, go back out. It should be symmetrical. You gotta give my graph a little bit of leeway. It should be symmetrical. So the dashed lines are actually not there, and all you would be seeing is the two arcs, and that's the hyperbola. Okay, so that is what a hyperbola looks like, and this is the way we're gonna go about graphing it. Now, a couple definitions here. We're going to have two vertices. Okay, we're gonna have two vertices. And the foci, so we're gonna say vertex 1 and vertex 2, and the foci actually come and fall outside of the arc. So here would be foci 1, and here would be foci 2. And that's because, remember, these two guys are here, and we're going so the actual hyperbola falls inside them. Okay. Now, we've got this rectangle here, and we've got from this vertex to this vertex. This is called the transverse axis. Transverse axis. Yeah, I'll write it again down here, transverse. And the transverse axis is the axis that goes from one vertex to the other vertex. But we actually have another axis as well. We have this guy, because look at our guide box like here. So this guy is called the conjugate axis. Now, I don't want you to get into the habit of thinking that the conjugate axis is always just going to be the vertical one and that the transverse is the horizontal. The transverse is the one that goes from vertex to vertex. So if this thing was rotated all the way, it rotated somewhere, that axis changes. The conjugate axis is just the other than 90 degrees from the transverse axis, okay? But the axis doesn't need to be vertical versus horizontal, okay? So with that being said, when we go to look at the formula here for the hyperbola, it's going to look similar to everything that we've done before, so the formula, with just a couple little changes. But there are going to be two formulas. So the first one that we're going to look at is the one that has a horizontal transverse axis. So horizontal, that is a V, not a T. Transverse axis. Okay, and that means that the arcs are opening to the side, like just what we've got going on here. And the horizontal transverse axis formula looks like this. X minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, see where we're going with that? This is a subtraction, not an addition. So you now have to be very careful when you look at the problem that you see that subtraction going on there. So the x's come first, and then the y's come second. Now that looks like the norm for us. But if we had a vertical hyperbola or a vertical transverse axis, then the formula, it's still going to look very similar, but it's definitely different. And so now you have something more you have to pay attention to. Here's what the formula looks like here. Y minus k squared over b squared minus x minus h squared over a squared equals 1. So if the y's come first, it means that your hyperbola is now opening up and down. So the two become very important. All right, so let's look at an actual formula, and then we're going to use what we just did here to draw this next guy. So let's say that we had y minus 2 squared over 4 minus x plus 2 squared over 16 equals 1. Now, is this guy going to open to the side, or is it going to open top and bottom? It's going to open top and bottom because the y is coming first. Now, when we think about the center, which means the middle of this whole situation, don't get caught on this. This guy still comes first. So it's -2, +2. So that guy comes here, and this guy comes here. So there's a lot to think about when this one flips around. So that's where we start. So we start by finding that point. So we're gonna go over 2 backwards, and up 2. So there is where we're starting. Now, what we want to do first is find our 2 vertices, or second, I guess. We got our center. We want to find our 2 vertices, and that's going to come from the transverse axis. And remember that this guy right here is going to be the b squared. It's not b. So when we look at our radius here, we're looking at 2, which means we're going to go up 2, right, because it's the line. So we're going to go up 2, and we're going to go down 2. And then this one is underneath the x, so this is the horizontal, and it tells us that we're going to go horizontally 4, right? So we're going to go 1, 2, 3, 4 this way, and 1, 2, 3, 4 this way. Now, we are not going right in and drawing our hyperbola yet. We're going to draw that guide box first. So we're going to draw the box that goes through these points. Okay. So that's how we get our guide box, is by using the center and then the 2 radii. Now, can you see here how there could be an oval in between if that had been a plus? But instead we have flipped it inside out, so we're going to go with the hyperbola. So that means we also want to put in those diagonals. So we're going to draw the diagonal. And the first couple times you do this, you will not be very good. You won't hit all the points, but you just do the best you can. Okay. I actually do better drawing dashed lines than regular lines. Now, remember that it opens up and down, so there are our 2 vertices right there. So we're gonna hug the asymptote, the diagonal line, come in, hug it going back out. So we are very wide on this one. It shouldn't have a bump there, but who cares? And then we try to draw this just symmetrically. And of course I can't ever draw anything symmetrically, so, except I did put another bump in there, but. Okay, so we've got this very, very wide, much wider than the first one we drew, but this wide hyperbola, okay, that's opening up and down. Now, again, this from here to here, that guy is the transverse axis. This one is the conjugate axis. Okay, conjugate axis and the transverse axis. And just like we talked about minor and major with the ellipse, you can also talk minor and major here. Even though this guy opens up and down, the major axis is still the conjugate axis, isn't it? Because it's bigger. So this guy is still the major axis, and this guy is the minor axis. So just because of where the y is there first rather than second doesn't necessarily mean that your major axis has to be here. The major axis still means the bigger one, and the minor axis still means the smaller one. It's the conjugate and transverse that mean which way does it open. So when it comes to a vocabulary question, that might be sitting there for you, okay? And it's probably gonna come up as you start to read through the problems. Now, I am not interested so much in you like figuring out what the equation of the diagonal lines or anything like that is. I just want you to be able to graph it. So that's all we're focusing on, is being able to draw, find the center, find your points here, draw the guide rectangle, draw the diagonals, and when I see your work, I should see all of that, okay? I shouldn't just see, okay? I can draw that too, but that doesn't tell me that you understood all of the different parts. So drawing in the guide rectangle and everything, that's all part of your work, those asymptotes. Just like they were part of your work when we were doing decay and growth functions, they're part of your work here. Okay, so there is the hyperbola. Just remember the minus, changing it from an ellipse to a hyperbola. All right, guys, sounds good. See you next time.